All right, everybody, let's find the centroid of this three-dimensional shape. It's comprised of three different parts. There's a cone here on the left end, and the radius of that cone is r, and the height of the cone is h. There's a cylinder in the middle. The radius of the cylinder is r. They all have the same radius. The length of the cylinder is L, and then there's the hemisphere, and the radius of the hemisphere is r, right? Okay, so what I want to do is find out where the centroid is. I'm going to make my life simple, and I'm going to put the y-axis right here, and the x-axis here. And so the center of the cylinder, right, the center of the cylinder, geometric center of the cylinder will be the y-axis, or the y-axis passes through the geometric center of the cylinder. In fact, let's redo that a little bit. And let's go with the y-axis that way, the x-axis that way, and this is three-dimensional coming out of the board, the z-axis that way. The z-axis comes out of the board. All right, so remember, an integral is a sum. So in order to find this, I'm going to do the sum of everything. Well, symmetry, again, let's talk about symmetry. Symmetry tells me the centroid is going to be along the x-axis here. So the y value of the centroid will be 0. The z value coming in and out of the board of the centroid will be 0. Okay, because it's going to fall on those axes, or at the origin that way, right? Somewhere along the x-axis. The centroid is somewhere along the x-axis. So I don't really need to worry about x bar. So to find x bar then, I'm going to have to take the x position of each centroid times the volume. Remember, x bar was equal to the integral, let me do it down here, x bar equals the integral of d volume here, and then x d volume there. But this is all fixed points, right, or fixed sizes. I don't need to integrate. So it's going to be x bar of each of these. So we start with the cone. All right, so if I look up the centroid of a cone, I find out the centroid of a cone is going to be over here, and this distance is h over 4. Now, I'm in the middle of this, so the centroid of the cone is going to be minus L over 2, because I have to go left L over 2, and then left a little bit more, I have to go left h over 4. So there's the centroid of the cone. Then I need to multiply by the volume, right, the d volume. So the volume of the cone, and that's 1/3 pi r squared h. 1/3 pi r squared h is the volume of a cone, right? Then I go to the cylinder, but the beauty of the cylinder is I've placed the origin, because I want to make it at a nice location, I've placed the origin at the middle of the cylinder. Okay, I've placed it at the middle of the cylinder, and so that's just 0. The x bar value for the centroid of the cylinder is at the origin. I'm going to multiply by the volume anyway, not that I really have to, and that's going to be pi r squared L. Right? And then I need these volumes in the denominator, 1/3 pi r squared h down there. I need pi r squared L. And then finally I have the hemisphere, and it turns out the centroid of the hemisphere is 3 times the radius over 8. But that's from here. 3r over 8 from here, but I'm also L over 2 there. So the centroid of the hemisphere is going to be L over 2 plus. Notice this one's negative because it's to the left of the origin. This one's positive because it's to the right. So L over 2 plus 3r over 8. And then it's a hemisphere, so the volume of a sphere is 4/3 pi r cubed. Right, let's bring that all the way over, but I don't have a sphere, I have a hemisphere, so we take half of that. So instead of 4/3, it will be 2/3. So then I get 2/3 pi r cubed. And if I had numbers, I would put them in, but I don't, and I don't care. So the x position of the centroid is given by this. If I move the centroid, or the origin over to here, it'd be basically the same thing. I mean, it's not going to change where the centroid is. It's simply going to change the label of where the centroid is. But I would just go left h over 4, and then this would be L over 2, right? Because that would be L over 2 from this origin here, and then this would be L plus 3r over 8. So it wouldn't make much difference really. The mathematics would be different, but the answer would be at the same place, wherever that place is. All right, so again, composite parts. The integral is a summation. And so you take your integral, you turn it into the sum. Here's all the volumes for the summation down here. Here's the sum of the x times volume for the three different pieces up there on top. All right, so that's how we do centroids in 3 dimensions. However that's set up. Where you put the integrals, or excuse me, where you put the origin will make your life simple. Sometimes it's set, you don't have to think about it because it's been done for you, but sometimes you have to make that decision. All right, if you have any questions, please leave them in the comments below. Thank you.